Okay, so here we have a 2D problem about a structure, and what it's asking is to find the resultant force in the D, which is up here, and to find the resultant force in the G. Okay, so the first step in any problem should be to draw a free body diagram. I already did that here, and I already drew the forces. Um, the forces are something tricky to see if they're going left or right or from up and down. Um, so you're gonna be able to tell as we go on. We're gonna be able to tell if you drew them in the right direction. So the next step should be putting everything into the equilibrium equation. Remember, the equation should be equal to 0. So, for example, you should always start with moment, and you want to find f of x, f of y. Okay. Now, if we do this, we're gonna realize that we have way too many unknowns. We're gonna have a million unknowns, and it's more than we want for a 2D problem. So what we do is we just simplify it, and we take this whole system and we find the moment. For example, in this case, we find the moment in one point to one of the other points in one of the members. For example, what you do here is you break this down and you find the moment from F to G. So if you do this, you're gonna realize that you go from having, and that's a good thing about members too. For members, what they do is they are going to go from two unknowns to one unknown, and the reason being is because if you notice, this is the line of action, and obviously the force is gonna go here, and there's gonna be a force here. But when you're finding the moment, you're gonna realize that for example, the g of x, if you're finding the moment of f, the g of x, you're gonna times it by 0 because there's no distance in the x component and the x force, so that eliminates the x component of that member. So you only have to worry about the force in the y direction now, right? So the moment of f would be the g of y times this distance, and the distance is 2.2 equals 0, because remember, in the equilibrium equations, everything's going to be equal to 0. So right away we can tell that the equation, or g of y, is going to be equal to 0. So we can say here g of y is equal to 0. Okay, now what we need to do is come up with a bigger moment formula that involves the whole system as one, right? For example, the easiest point that you would be you would pick would be a point that is connected to both G and both D, right? So for example, when you look at this whole system, there's one point that connects both G and D, and that would be B right here. So what we do is find the moment. You find the moment around B, okay? And we can go ahead and start with D up there. Obviously, when you start looking, the only thing that matters here is D of x. So D of x times the distance in the y, so it'll be 3.3 plus 2.2. Okay, then you move on to plus the 104 times the 2.2 because it's the distance in the x, since the force is going to the y direction. And the last thing that you have to worry about, it would be g of y, and the reason being is because it has a distance in the x. So it would be g of y is already given to it, or not given to us, but we already found g of y, it's 0. And 0 times 2.2 plus 2.2 plus 3.3 is 0. So obviously we're not going to worry about that, and we're going to equal it to 0, right? So now we just do the, gotta find my calculator. So we do the 104 times 2.2, and we get 228.8. So it would be 228.8. Sorry, and that's what I forgot. Since we're doing moment, we gotta see if the moment is going counterclockwise or clockwise to see so you can determine if it's a negative or a positive moment. In this case, the d of x, if it's pushing on the right direction, if it's pushing that way, that's going clockwise, so it'll be negative. And the 104 here is going down, which is going counterclockwise. Yeah, counterclockwise, and it's going to be positive, right? Therefore, the 228.8 is going to be equal to dx 5.5, and then we divide 5.5 from both sides. And we get 41.6. So dx equals 41.6. Okay? Now what we do is we find the sum of the x. Let me bring this more right here. What we do is find the sum of the x for all points, which would be dx, which is already given, 41.6 plus g of x, which is obviously we haven't found yet, and that's it. So now what we're going to see is that g of x is equal to negative 41.6. Okay? In this case, g of x doesn't really matter. But I was wrong, because g of x in this case it will be negative g of x because it's going to the left. So I mean it will be 41.6. You're gonna see later on it doesn't really matter if it's positive or negative, because at the end of the day the g of y is 0. But this is important if the g of y wasn't 0. But in this case it is, so we don't have to worry about it. So the g of x, we see that it's 41.6, and then we gotta find the sum of the y. When we find the sum of the y, we're gonna see that it's gonna be dy plus 104, or minus 104, sorry. And we don't know if this is positive or negative yet. We're gonna figure it out right now in a second. And then it's going to be plus g of y, which is 0. It's all going to be equal to 0. So d of y equals to 104. Okay? So the last step now is, if you're going to find the resultant force of anything, you got to remember the resultant force is equal to the magnitude. So it would be like this. To find the resultant force of D, for example, it would be d of x that plus d of y Okay, so we will simply add 100, or we'll just do 104 for d of y squared plus d of x is 41.6 squared, and we get 41.6 squared, 112. And this is f of d. Okay, and then you do the same exact thing for f of g, and it's going to be 0 squared plus 41.6 squared. And this is why I was telling you guys that the negative here doesn't really matter in this specific problem, because if it was negative here, the answer would still be the same. And f of g is going to be equal to 41.6. Alright, so that's how you do that specific problem.